Welcome back. This week I practice welding and bending skills so I can tackle the custom twin turbo intake manifold and build it all from scratch. In last week's video I explained why I would choose to build my own liquid to air intercooler piping and what it's going to take for me to actually do it. Since I'm starting from scratch, this means I need to get some practice. If you're new here, this channel is where I post weekly progress on my journey to build a customized twin turbo engine for my OBS Ford Bronco. I started from scratch, so I had to learn everything as I go. This project is huge and I am way out of my comfort zone here, combining engine building, digital engine management software and hardware, custom fabrication, and welding. Not to mention learning how to film, edit, and publish these videos. First up is finishing the random container I started last week. This was scrap metal I had laying around. I've been welding coupons for a while now, but nothing builds skill faster for me than direct application. So here I am screwing up a bunch of welds, but figuring out how to suck less. I'm going to do some talking with my hands, this old Tony style, but essentially, this is what we got. This is what I ended up with. Here's the bad and the ugly. This is where I started off though, and I think the bends came out fantastic. I got all those kind of square and neat, but the rhythm, it was a little tricky. I had to get back into the practice of TIG welding, but as I moved on, things got a little bit better. I kind of jumped around all over the place on this, so some welds look a little more uniform than others, but these look pretty good. These are all done in sections. Looks like about 10 dabs or so each. Some of these didn't turn out so hot, but I think that gave me a lot of good confidence. I think that this is a pretty good accomplishment for somebody just starting off TIG welding. So that also gave me an excuse to build this little device. And all this is a shade 10 auto darkening welding lens. And then I printed this little holder. Fits on my phone. I'd put the phone in there, but you know, I'm recording with it right now. And this works okay. As you can see from the footage, you know, it dims everything out. It lets you see what I'm doing. But the arc shots are a little blown out, and I'd like to do something about that. I'd like to see if I can get more of that puddle and less of the blown out, you know, white hot arc shots. I think that would be a little more informative for people to give some advice and tips and generally tell me how much I suck at this. This is the second project I did to get ready for welding and putting all these basic principles to use. Making sure everything's real clean. Doing lots of extra work fitment wise, you know, making sure everything fits up well. And this is really just to hold this contraption together while it straddles the transmission tunnel in the Bronco. Well, it's just melting apart. I think I need something to actually hold that together. Here we go. Vice grip to the rescue. I think that's going to hold it together a whole lot better and free up a hand so that I can throw some filler in there. There we go. That finally worked. Okay. Ooh-wee. Yeah, I was on there way too long, but I just could not get those puddles to fuse. Looks like it went okay. I'm just barely on the pedal here. It's working okay. Not Not too bad. Even if it was bad, it's mostly in hidden areas, so let's try this one next. I think I might try a different strategy. I might start on the larger sheet first and then move to the smaller one. Let's see if that helps. Well, it doesn't help when you bury the tungsten. Oh, that was much better. I get the puddle started on the big piece, that fill and chill method, then move over onto the small piece, and it seems to bond pretty instantly. I'm not going to go for that corner, it's a little too small. But I think what I am going to do is put another tack on this far edge here. That should be enough to hold everything in place. Could not quite get this filler rod in the right spot. Let's try that again. Okay, that's an ugly little tack, but I think it'll work. This is some supremely thin metal. I'm really dubious on how I'm going to get this one done. Try the same method as before. Try and go a little faster. I think that got it. Looks like I got it. That was a little tricky too. Boy, welding thin stuff is tough. That is difficult. But apparently not impossible. I'm not even going to attempt that. There. I think that's going to work okay. It's not super strong, but all this is really doing is keeping these in line, keeping it from wobbling too much. And it needs a little bit of wobble because of where it's sitting. So I think as far as a practical training aid, I'll buy it. All right. This should work pretty good. Last time I test fitted it, it was nice and snug. Yeah, that's pretty good. Let's see. Tuck it down. It just kind of jams in there between the shift boot and the seat. And then we can take our inserts here. Oh. Well, shoot. I was afraid of that. I'd have to get some smaller inserts. Well, there it is. So I bought this cheap electronic throttle body off of eBay. I have no idea how well it works, but it seems to be good enough for Corvettes, so I think it'll be good enough for me. I'll have to come up with a strategy for controlling this, and that's in a future video. For now, the immediate task is to adapt this throttle body to the intake of the 460, and since I'm using the stock intake runner, I'm going to have to custom build this thing. Step 2 was rendering the throttle body adapters in CAD and making sure that I had accounted for all the variability in the parts themselves. I also switched over to a FreeCAD version. This is actually called FreeCAD version 1.0. It's the first stable release of this open source project that's been in development, I think, for almost 20 years. This is an alternative to stuff like Fusion 360 and SketchUp. And it's got a steeper learning curve than the other programs, but after you get over that hump, I find it to be a very useful product. It's not as polished as the other commercial versions, but I do like it a lot, and it gets all the jobs I need done. I would still recommend starting on something commercial like Fusion 360 just to get over that initial learning curve. Uh, those make it a lot easier to understand how CAD works and how to train your brain into solving problems. Then moving on to something like FreeCAD is more of an option. And as it frequently does, the 3D printer makes a return appearance in this project, this time as templates. I found some half-inch thick extruded aluminum plate offcuts from my local metal supplier, so I got these for about $2.50 a pound. Unfortunately, I couldn't find one large enough to fit this whole side of the plate on, so I took two pieces, cut them in half, flipped them around, and you can see here I'm going to mark things out. It ended up being easier to cut this out on the bandsaw in two pieces. But that also means that I'm going to have to stitch these back together with some welding. And since I don't have a CNC mill yet, I had to use a very broad range of tools to get things done. None of it was pretty. It all was actually pretty rough. I ended up making a whole bunch of man glitter all over my garage. That's what that little diamond plate is for, is just to keep the glitter under control. I've never welded aluminum this thick before. I know some of the thermal properties are going to be a lot different than welding coupons. And remember, I'm still a brand new beginner at all this stuff. So I put some pretty heavy chamfers on this, thinking that I would get better weld penetration. I also wanted to make sure everything was clean and square to minimize the chances of warping. I ended up being successful in minimizing the warping. I think this part is pretty prone to warping, especially where I'm welding this. It's a very thin part and there's large sections coming out from either side of the weld area. And after verifying all the dimensions with the templates, I printed out this guide that I'll use later when I get to the routing part. For now, I'm super gluing this onto my bench and making sure that the top and the bottom aren't going to lift up when I weld the seams in the middle. I really only needed this super glue to hold it down temporarily until I was able to put the clamps on the bench. That way things didn't get bumped around and moved while I was applying the clamps. Once all the clamps were positioned and everything was tight to the bench, it was time for a big breath and to weld. After thinking about this for quite a while, I decided to start with the outsides edges, the sides that are least likely to warp. So I'm doing the outside and then the inside versus the top and bottom. I think if I were to start with the top and bottom, the flange would have a tendency to kind of lift up like a potato chip or a taco. And this way, I think the strategy is that I will bond these pieces together on the outside, and those will not have the tendency to warp in either direction. And is when I have those tacks in place, then I can move on to the top and bottom sections. And this blowtorch trick I had never tried before on the super glue, but I saw a video by a guy named Clickspring, and he uses that trick all the time. He uses super glue to bond brass pieces on his lathe together, and then hits them with a torch, and they seem to come apart just fine. And it worked great for me too. And I'm going to reinforce all these welds on the outside and then weld the top and bottom as well. And my goal here is to get maximum penetration. And like I said, I'm brand new at this. I don't intuitively know what it's going to take to bond half-inch metal together, but I'm going to do my best and run things a little bit hot and put a little more extra filler than I normally would think of to do. And that's just to ensure that I get really good penetration and that this part isn't going to crack under stress. For anybody curious, I'm just running straight AC TIG at 120 hertz. and I'm running about just under 200 amps here, so this will pretty much max the machine out. I don't have the pedal floored, so meaning I'm not using the full 200 amps here, but I'm getting darn close to it. Another option I considered was preheating, and I have the torch right there, but I found that after I had done the initial tacks when it was super glued to the bench, that the part had warmed up a little bit, and then as I reinforced those tacks, the part got hot enough that I didn't really want to add more heat to it. I think I would end up sinking way too much metal into the part. And through pure determination and a good bit of luck, these welds came out pretty good. They're all slightly proud of the metal, which is what I need for the next step. All right, well, that's as far as I could get this week. I pushed this to the absolute last minute that I had to spend on this, and it looks okay. Getting this a little flat with the sandpaper here, and this is a calibration plate. If you're not familiar with that, it's just a very flat granite surface, very dimensionally stable. This is used for measuring machining tolerances and things. So this is just flat, and it's flat enough for me to take this down to make a gasket sealing surface with it. It's not going to be perfect. I don't own a mill, so it is what it is, and it's good enough for what it is. Next week, I will focus on finishing this off. I'll finish off the other side as I have a little bit more time. Also, next week, I will be using my router table as a way to machine this precisely. I'll be using this 3D printed guide as an edge guide. I'll be using a flush cut trim router bit to trim the outside dimensions of this gasket. And I'll probably do some things like chamfer the edges or break the edges with something. And that should be the base plate for the throttle body adapter completed. And then once that's finished, we've got the throttle body side to do in a similar fashion. I'm really not sure how I'm going to cut out this circle yet, but same process. I'll be cutting it out on the bandsaw most likely, probably drill a hole, cut it around, and then clean things up with a file. And then I'll take this and I'll use this 3D printed piece as a template for flush cutting and getting everything even. Thanks for stopping by. I'll see you next week.